Hello, everyone. So, if you look at the top, the URL, satsweetquestionbank.collegeboard.org. If you're a junior and you have more time before finalizing this as your SAT score, obviously you can take more. This is a great resource to look at all the practice problems they have for not only math, but English. You can look for certain skills, whatever you're lacking on, and you can also sort by difficulty. So say your module 1 is pretty weak, you can go to easy, medium, and then if you want to focus on module 2 harder questions, we can sort to hard. It's very important. I'm not sure if this makes too big of a difference, but wherever you're located, just make sure to include that for the state standards, so you're not including questions that may not show up on your test. Additionally, you always want to exclude active questions because those are already on the practice tests on Blue Book that College Board offers. So, first you should be going through all of those, seeing where you're lacking, then going through these, exclude active questions, which are the questions that are on those practice tests. And then you can go through these and you can look for which ones you want. So we'll be going through only difficulty hard today, mainly because we don't have time to go through other difficulty questions, but I do think a lot of the hard ones, the quote-unquote hard ones, are very easy if you understand the concept at hand. On the SAT, the last 5 or so problems are going to be the ones that are very difficult, and if you understand, you can do it, and if you don't, it's going to be very hard to get there if you don't understand right off the bat. For me, it took a couple SAT tries to get my 800, but on my other ones, I did score 770 and a 790. So it definitely is possible to consistently get over a 750, but you're going to have some problem solving skills to solve the ones that are very, very difficult. Other than those last 5 ones, I do think it's very possible to ace the quiz or ace the SAT. Other than those, and that should net you like around a 750, 760. Depending on the difficulty, it could even curve higher because of their equating that they use. So yeah, I'm going to be taking some of these questions in different skills, and then we will go over them, and that should be it. Hello, everyone. So I clicked one problem from each skill. I exported it to Notability so that I can look at the end, or I can look at the question, go over it with you, and then we can look at the answer below. I'll be going over the correct answer choice, which is below, and I'll just confirm it with you guys so you guys trust me, of course. After we do the problem, I do encourage you to pause the video every time you see a new problem. Try it for yourself. If you don't get it, or if you don't understand how to do it, then you can watch my explanation and then look at the answer. Try it for yourself, and that should be the best process. So again, I'm going to go through with you guys. I'm going to read every problem, and we're going to just go through it as fast as possible. So let's read through it. So Hector used a tool called an auger to remove corn from a storage bin at a constant rate. Constant rate is pretty important. The bin contained 24,000 bushels of corn when he began. So the starting amount is 24,000 bushels. After 5 hours, he had 19,350 bushels left. If the auger continues to remove corn at this rate, which is the constant rate above, what is the total number of hours Hector will have been using the auger when 12,840 bushels of corn remain in the bin? Okay, so the first thing that I'm thinking is we have a constant rate that is taking away from our 24,000 bushels. To solve for this rate, we know that we started with 24,000, and we're subtracting 5 hours times the rate, which is bushels per hour. So we have 5 hours times our rate, which we can just label R, equals whatever's left after that 5 hours, namely 19,350, okay? So using algebra, we know that we can add 5R to both sides, and so we can isolate for R, right? So add 5R to both sides, subtract 19,350 from both sides, and what that's going to net us is 24,000 minus 19,350 equals 5R, okay? Using our calculator, we can solve for that. So give me a moment. And remember, you will have Desmos for every problem. So while I'm going through it by hand, and I'm using my calculator to the side, you will have Desmos that you can not only use to graph, to visually see, but to use as a calculator, okay? So I subtracted 24,000 minus 19,350. I got 4,650. equals 5r. And then to solve for r, divide 5 both sides. And that's going to give us r equals 930 bushels per hour, right? So this is our rate. We now want to know how many hours using this rate given will it have taken to go from 24,000 to 12,840. So we start with 24,000. And again, we're subtracting a rate. We're subtracting the rate we know, but we don't know how much time it takes, right? We're trying to find the time. So we're going to put t here, time times the rate. We know the rate's 930. And that equals what number we're looking for, right? 12,840. So again, we're going to solve for t this time instead of r. I apologize if this is getting a little bit messed up. It's a little bit zoomed in. So we're going to add t times 930 to both sides, of course. And then you're going to subtract the 12,840. So we have 12,400, or 24,000 minus 12,840. And this equals 390t. Okay? So after we do that, so we'll do 24,000 minus 12,840. That's going to give us 11,160. (930t). And then we're going to divide by 930 on both sides to solve for t. And that's going to give us 12. So t equals 12. So it took 12 hours from when he began to have 12,840 bushels of corn remaining in the bin. So if we go over it again, we started with our rate, found the rate, then we looked back, used the rate to find time. Okay? So it should be D. Look at the answer. Perfect. D. And these are all the hardest difficulty questions, so you don't have to worry about that. Okay. An economist modeled demand for Q for a certain price as a linear function. So when we think of linear function, we think of y equals mx plus b. Okay. So just keep that in your mind. Whenever they say linear, you want to recognize that that means y equals mx plus b. Okay. As a product function of the selling price. Okay. The demand was 20,000 units when the selling price was $40 per unit. And the demand was 15,000 units when the selling price was $60 per unit. Based on the model, what is the demand in units when the selling price is 55 per unit? Okay, so we have the demand Q, which is a function of the selling price P. So our Y is Q, our M is the rate at which they are connected, times P plus B, and there. Okay. Another equation that's actually pretty important is called the point slope formula. And because we're given 2 points here, namely 20,000, 40, and 60, 15,000, it might be easier to use the point slope formula, which basically allows us to use an equation where we can plug in for 2 points to find the slope, right? And then we can move backwards to solve for when it's 55, okay? So here we have y minus y1, so q minus q1 equals m x or p minus p1. Okay, so we know q1 and p1, and we have 2 points, so we can plug in for q1, q, p, and p1 to solve for m. So our first point is going to be 40, 20,000. Your second point is going to be 60, 15,000. And this makes sense, right? As the price goes up, less demand, right? Because less people are willing to buy at a higher price. So let's plug in for Q and Q1. And we can label either one as Q or Q as just regular Q or as regular Q1 and P1, right? So we'll call the top Q or Q and P, P1, Q1. Okay, so let's plug in. 20,000 minus 15,000 equals m. 40 minus 60. Okay. Left side is going to be 5,000 equals m. times negative 20. So we divide by negative 20 on both sides. We get m equals 500 divided by negative 2, which is negative 250. Okay, so now we know our m. Okay, so we can go back into the equation and we can plug in what we know, the 55, and then we can solve for what we're trying to find, right, which is demand when P is 55, okay? So let's go back to the Q minus Q1 equals M P minus P1. I'm going to erase a little bit here, so make sure to take everything in visually. Let's just erase it at this point right here, right? And we're going to plug in for Q. Q is what we're trying to find now, right? Q1 we know. Q1 can be any point that we already have. Or, sorry. Yeah, Q1 can be any point that we already have, right? So we can just use this top coordinate for Q1 and P1. And we can use this new P, which is 55, for Q as well. Okay, so we have Q minus Q1. Q1 is the point that we know. So that will be 20,000. That's the demand. Equals M, we just solved for slope, negative 250. P, we know P, right? It's 55 because we're trying to find the demand when the price is 55. And we subtract, again, the price associated with that demand that we plugged in, which is going to be 40, okay? So here we have Q minus 20,000 equals negative 250 times parentheses 55 minus 40. So firstly, we're going to work in the parentheses, 55 minus 40. And that's going to be 15. So in here is 15. And then do 15 times 250, or negative 250. Negative 3,750. This equals the Q minus 20,000. Okay, and I'll clear more space here, so make sure you have taken in everything that's shown. The last bit is to solve for Q, right? So to solve for Q, you're going to add 20,000 to both sides. And then that should be, if we put that in the calculator, 16,250. A. Okay? So we use the point slope formula to find M. And then we used M and reverse engineered it to the point that we're trying to find. So if we go up above again, we did the same thing here. We used the first equation to find R, and then we reversed and used R to find T. So usually the process is you're going to be finding a variable, and you're going to be using it, right, based on the equation. So we look at the answer. Correct answer is A, okay? Let's check my battery. Battery is perfect. The graph of the equation AX plus KY equals 6. And this is a line in the XY plane, so this plane. And A and K are constants, so they can be like 2, 1. They exist to all real numbers. If the line contains the points negative 2, 6, usually when I'm working, I love writing down the information they give me. Even if it's in the problem, it's good to be able to just look here and not have to decipher the problem again. So I have the 2 points on the right side. I have the line that we're using, and I'm trying to find the value of K. Okay? So we know X, we know an X1, Y1, and we know an X2, Y2, right? So what I'm thinking is if we plug those in to this equation 2 times, we'll get a system of equations where we can solve for A and K. And we're trying to solve K, right? So because we have an equation and we have 2 points, I'm thinking plug them in, get a system of equations. And because we have 2 variables, we can solve for both of them, right? So if we plug in the first point, x1, y1, we'll get A times negative 2 plus K times negative 6 equals 6. And if we plug in the bottom point, you have 0, right? So A times 0 is 0. We plug in K, or we plug in for Y, we get negative 3K equals 6. Okay, so if you look here, they literally already solved it for us just by us taking the time and plugging in this point, right? So we have negative 3K equals 6. If we solve for K, we get negative 2. Very simple. Very easy. They lay it to you on a platter. You literally give it to you. Okay. Next problem. Oh, I apologize. I've been showing the answers. Going a little bit too fast. Okay. Adam's school is a 20-minute walk or a 5-minute bus ride away from his house. So we have point A, house. Point B, school. So school, house. We know this is a 20-minute walk or a 5-minute bus ride. The bus runs once every 30 minutes, and the number of minutes, W, that Adam waits for the bus varies between 0 and 30. Which of the following inequalities gives the value for which it would be faster for Adam to walk to school? Okay, so if we're starting at time 0, we want to find how long we're waiting would compensate for that 5-minute bus ride, right? So if the bus ride is 5 minutes, we know that the total time both waiting and going to school could take is 5 plus the time he waits, right? Because you have the 5-minute bus time plus how much time he waits. And we know that this varies from 0 to 30. So it could vary from both if he waited 0 minutes, it would just be a 5-minute bus ride, right? Or if he waited 30 minutes, it would be 35 total minutes. So this is going to be the upper and lower bound, right? And the bound that we want is when it is equal to or is when it is less than 20 minutes, right? Because if he waits more than, if he total time takes more than 20 minutes for him to both wait and take the bus ride, it would be more worth for him to just walk, right? It would be more worth it for him to walk if it takes more than 20 minutes because he would already be at school by the time, he's riding the bus and waiting, okay? So we either have a 20-minute walk or we want 5 plus W, which is the total time it takes to both wait and use the bus, to be less than the 20-minute walk, right? Because then it's worth for him to wait and take the bus ride, okay? So if we look at our option choices, it's just going to be C. Apologies. It says it would be faster for Adam to walk to school. I apologize. So again, if you want it to be faster for him to walk to school, then you want to wait and you want the time for him to be waiting and going to school to be greater than walking, right? So you want the time it takes for him to wait and go to school to be longer than him just walking to school. And that's why you would get D. Okay, apologize. You should be reading the question better than I am, hopefully. Just trying to get through this as fast as possible for you guys so I can upload this. Okay, so we're given a quadratic equation in the vertex. Hello, everyone. So, sorry I had to cut the video, but we're back. So we have this quadratic equation, and we have 2 points, which are when it intersects the x-axis, right? So these are our x-intercepts. On Desmos, I will switch over to Desmos in a second. All we have to do is it's asking us, well, we know that it intersects at 0, 0, but we want to know what is this other x value that it intersects the x-axis at, right? So you have to do 0 calculations here. We're literally just going to hit up Desmos, desmos.com, and this is going to be on your exam, by the way. So we have, and we're going to type it in, 2x minus 4 squared minus 32. And this is our function. And this is exactly what's going to be on the SAT. Literally, you get Desmos, you're going to use it to your advantage, okay? We see 0, 0, which is the point they give us, and they say, well, we want to know T0. If you look here, we see the point is 8, 0, so T, logically, must be 8, okay? So we go back, we look, and we say, okay, well, 8 is 0, and we go on with our lives, right? Like, we're done. That problem is over with, just by using Desmos and having to do absolutely nothing else, okay? Let's see if I can not show the answer this time. Because of time constraints, this video might have to be cut short, but with that being said, let's keep continuing. So with this problem, we see that we're trying to find AB so that we can find the value of A times B. We have 2 sides which are equivalent to each other, right? With polynomials on both sides. So the first step that I'm looking is if we're given information, we usually just want to expand it out. We want to get all the information in the simplified form so that we can analyze it from there. So I'm going to distribute the AX to all the terms. Now I'm going to distribute the 3. Okay, so now I want to simplify this, obviously. Oh, and the answer is just sitting right there. And so from here, we want to compare the polynomial. So, for instance, if we take 20x to the 3, we have only one x to the 3 term here. So 20x to the 3 must be. So we're going to equate both x to the 3 terms. So we have 20x to the 3 on the right side, and on the left side, the x to the 3 term is this. So taking out the x to the 3 terms, we can see that 20 equals 5a, and then therefore a equals 4, right? So the next thing that we're going to do is we're going to work with the squares, right? So if we combine like terms on the left side, we get negative ab x squared plus 15x squared equals the x squared term on the right side, which is negative 9x squared. So we can cancel out the x squared from all sides. And then if we plug in a here, we get negative 4b plus 15 equals negative 9. So then we can subtract 15 from both sides and get negative 4b equals negative 24. And therefore, b equals 6. Right? If b equals 6, then we know that a times b will equal 24, netting us answer choice. 27 different numbers, and the mean is 33, and our median is also 33. A new data set is created by adding 7 to each number in the original data set that is greater than the median and subtracting 7 from each number in the data set that is less than the median. So imagine we had 1, 2, 3, 4, 5. The median and mean would both be 3, right? Now we're going to subtract 7 from each of these. We're going to add 7 to this side. Therefore, our new data set would be negative 6, negative 5, 3, 11, 12, right? So this gives us the same median and mean, so we know that it can't be A, it can't be B. We know that the sum of these is going to stay the same because we subtracted the amount that we added. So by process of elimination, it has to be D. Another way that we can visualize this is away from the median and mean, which is 3. These numbers deviate a lot more, right? Like this is 7, and this is 9. Here it's only 1 and 2. So obviously the deviation from the mean and median here is much greater, and therefore that must change. Okay? If you look, that's D. This shows the scatter plot above shows the federal mandated minimum wage every 10 years between 1940 and 2010. Okay, a line of best fit is shown with the equation, okay? What does the line of best fit predict about the increase in the minimum wage over the 70-year period? So here, we can see that at 1940, it's basically saying that the minimum wage in dollars per hour was this. Negative 0.488, which we know is not true, but from the line of best fit, it gets that. We know that it's increasing. The minimum wage is increasing $0.096 per year, okay? And that's what the slope means. It's the Y units over the X units. So therefore, the dollars per hour is increasing that much per year, right? Okay? So if we look, we can look at a couple statements. Each year between 1940 and the average increase in minimum wage. Okay, so this could be correct. A could be correct. So we know it can't be this one because this is just the starting salary or the starting dollars per hour. Every 10 years between the averaging was 0. Okay. So here it also increases this, and that says every 10 years. So perhaps it could be that one. Every 10 years. Okay, so we know it can't be B and D because they interpret the slope incorrectly. Therefore, what it has to be is A and C, obviously. But here, we know that when you look at slope, that is how much it increases for 1 year, right? Because if you're looking at years since 1940 and the increments are 10 years, that doesn't matter. It's just per 1 year is what the slope is looking at. For 1 year, you get how much do you go up in minimum wage. And so, therefore, it would be A, because it says each year, not every 10 years. Okay, the same 20 contestants on each of 3 days answered 5 questions in order to win a prize. Each contestant received 1 point for each correct answer. The number of contestants receiving a given score on each day is shown in the table above. By score. Okay. No contestant received the same score on 2 different days. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or day 3, given that the contestant received a score of 5 on one of the 3 days? Okay. So here, we know that no contestant received the same score on 2 different days. So therefore, if they scored a 5 on day 1, they cannot score 5 again. Okay? Likewise for 4, 3, 2, 1, and 0. Right? If a contestant is selected at random, what is the probability that the select receives a score of 5 on day 2 or day 3, given that the contestant received a score on 5 on one of the 3 days? So, we want to look at the probability. We know that they scored a 5 on one of these days. Okay, so the total number of people that scored a 5 on one of the days is 7. We want to know what's the probability that that happened on day 2 or day 3, right? Where's the answer? Oh, maybe you just put in the answer. Okay, perfect. So for me, if we just look at the number of times that it happened in day 2 and day 3, which would be 5 over, and we look at the total times that it happened, which would be 7, we could just put 5 over 7, right? So when you're looking at probabilities and they tell you you're given that they scored a 5, you want to narrow down your search to 5 out of 5 instantly. Then you want to take the total number of times that people scored or people got something, an event happened. The total number of times that this event happened was 7 times. They ask us what is the probability that it happens on day 2 or day 3 specifically. So we look how many times did the event happen on day 2 or day 3, and we put that number of times event over the total number of times event, right? And you just get 5 over 7. Okay. In a study of cell phones, 799 randomly selected U.S. teens were asked about how often they talked on the cell phone about their texting behavior. They talked on a cell phone and about their texting behavior. The data summarized above, based on the data, an estimate of the percent of U.S. teens who are heavy texters is 30%, and the associated margin of error is 3. Which of the following is a correct statement based on the given margin of error? Okay. So, 30% of the teens are heavy texters. So that would be, does not talk on cell phone. Okay. So talks on cell phone, does not talk on cell phone. So this would be the heavy texter, 74. So, 30%, okay. Where heavy texters is 30%. Okay, so I believe they're talking about this percent. Talking about this heavy over the total is 30%. And the associated margin of error of heavy texters is 3%. Okay, so it can go from 27% to 33% are heavy texters. This is our margin. Look at the answer choices, the doubtful. So if we look at approximately 3% of the teens who are classified are not really heavy texters, so that does not correlate with what the margin of error means. That just means that the amount of heavy texters can bleed from 27 to 33 and not be exactly 30. So it can't be that one. It is not possible that all the teens is less than 30. So when you have a margin of error, it's not saying that this is 100%. It's just saying that this is like the most possible range, right? So it is possible because this is a sample and therefore there could be error outside of the predicted error, but it can go less than what they're saying. So therefore, it cannot be B. If we look at C, it says the percent of all U.S. teens who are texters is 33. So this is not talking about all, first of all, because it's a sample, so we cannot make conclusions about all U.S. teens. So because it says all, that verbiage instantly tells us that it's wrong, and it cannot be C. If we look at D, it is doubtful that the percent of all U.S. teens who are heavy takers is 35. So if we look at our range, 27 to 33, we know 35 is outside of that range, so it's unlikely for that percent to occur, and therefore we should be doubtful. So in that case, it's D. Okay, moving on. A sample of 40 fourth grade students was selected at random from the 40 students completed a survey about the morning announcements, and 32 out of the 40 thought the announcement were helpful. So H. Which of the following is the largest population to which the results of the survey can be applied? So when you have a survey and you sample from a certain group, so in this case, the group that we sampled from is fourth graders. The result that you get from a survey the result that you get from a sample survey can only be applied to whoever you pulled the sample from. So if we only pulled from fourth grade students, then we could only generalize the results to all fourth grade students. Okay? So that's B, right? So all students, it didn't take from all students, it took from only fourth grade students. The 40 students who surveyed, yeah, you could apply it to them, but we want to find the largest population, which is going to be who you surveyed from, the fourth graders. Again, we didn't survey all fourth graders in the county. We only selected them at a certain school, so it cannot be D, C, or A. Okay, we're almost there. Moving on. Apologies. So a manufacturer determined that the right cylindrical containers with a height that is 4 inches longer than the radius. So this is approximately the drawing. Let me get my calculator just in case. Let me open that up. I need it for this one. Okay, it's open. Okay. So we know that there's a height H. And H is 4 inches longer than R. And the R is this. So when we see this picture, we know that H is from the bottom to the top. R is for this circle. And that's all we need to know for the measurements, right? We know that the height is 4 inches longer than the radius. And that offers the optimal number of containers to be displayed on the shelf. Which of the following expresses the volume in cubic of such containers where R is the radius in inches? So if we look here, they're all in terms of R. None of them are in terms of H. So when we look at the volume formula for a right cylindrical container, it's simply just going to be this, the area of this, times the height, because we need to extend that area down, right? So if you may recall, the area of a circle is pi r squared, right? And then we need to multiply that by the height, of course, and that gives us volume, okay? So again, we need to do everything in terms of r, so we need to plug in for h. So pi, volume equals pi r squared times 4 plus r, right? So volume equals pi 4 pi r squared plus pi r cubed. Pi r cubed plus 4 pi r d. So again, we want to look at the formula for right cylindrical shape, which is volume equals pi r squared h, because you need the area of the circle and you need to extend that down. Then we get the variables in terms of each other. So we need to set height in terms of r, right? Because we're given that height is 4 inches longer than the radius. So radius plus 4 equals height. Then we look at the equation, plug it in, simplify. So if we know this is triangle ABC and it's a right triangle, we can apply SOHCAHTOA to it. The above is a right triangle, and sine B is 5 over 13. So sine B is going to be opposite over hypotenuse. So let's look where angle B is. This is angle B. If you take the opposite, which is this length, so we're going to label this, we'll label this side just B, or lowercase b is better, okay? So B over 26 equals sine B, right? Okay, and that's just the definition of sine theta, opposite over hypotenuse, SOHCAHTOA. Okay, and it tells us that sine b also equals 5 over 13. So we have a discrepancy. We have b over 26, which we got from this image, and we have 5 over 13, which they just told us. So all we have to do is find b, right? To find the length of AC. And then we can use that to find. So if we look here, if we multiply 26 to both sides, we get b equals 26 times 5 over 13. We can simplify this to 2 and 1. So b equals 2 times 5, which is 10. Okay? So now we know b is 10. So our triangle, and again, this is a right triangle, so we can apply Pythagorean's theorem. So this is length A, length B, and 26. We know what b is. B is 10. So 10 squared plus a squared equals 26 squared. And all we have to do is solve from there, right? So if we go in our calculator on Desmos, desmos.com, perfect. Then we do the square root, 26 squared minus 10 squared, we get 24. Beautiful. So we know that the missing length A is 24. Okay, correct answer is 24. Circle above has center O, the length of ADC is 5 pi. And x equals 100. What is the length of ABC? Okay, so in a circle, you have 360 degrees. So 100 over 360% of the arc, which is 5 over 18, 5 over 18% of the arc is giving us 5 pi. So now we want 13 over 18, the arc, right? So 5 over 18 of the total arc, which we'll just name A, equals 5 pi, okay? So A, which is the total arc amount, if we divide by 5, multiply by 18, equals 18 pi, right? We want 13 over 18% of the pi because that's the ABC, right? So, therefore, if we multiply 18 pi times 13 over 18, because that's the percent that we're missing, cancel out 18, you get 13 pi. B. Okay? And it looks like that's it. I hope you enjoyed. I'm sorry for publishing this very late. Perhaps some people in the morning will view it, and perhaps some people tonight studying very late will view it. So, have a good night. Take care.